about that seem to distinguish us as individuals, things like consciousness. Can we build computers? Can we build machines that have consciousness? And AI is really about getting computers to do these kinds of things. And issues like consciousness are still some way off, but over the last 2 decades we've seen tremendous progress in all of these things. And what we're going to hear about over the next 20 minutes is some examples of the progress that's been made. Why has progress been so swift in the last 2 decades? There are a number of reasons. There are scientific breakthroughs, but also it's the availability of large amounts of data provided by the World Wide Web, and the fact that computer processing power is now much cheaper than it ever has been. Okay, so what is IJCAI? Well, since 1969, IJCAI has been the main forum for presenting scientific research results in the area of artificial intelligence. It's been held, roughly speaking, every 2 years since 1969. 2015 is the first time that the conference has been held in South America. The conference rotates around the world, typically between North America, Europe, and the rest of the world, but this is the first time that it's been held in South America, and we're tremendously happy to visit Buenos Aires. This is a record-breaking conference. There were 2,000 scientific papers submitted to the conference, and each of those papers received 4 peer reviews by scientists working in the field to evaluate how good that paper was. And less than a third of those 2,000 papers submitted were actually accepted for the conference. There are nearly 100 associated events attached to this conference, and we have 1,300 delegates visiting the conference from all across the globe, from every continent. So this is really a boom time for AI, because there have been these tremendous breakthroughs in the last 2 decades. And if I have to identify just one breakthrough work that you should go and look at, one item that you should go and look at, I would point you at the invited speaker Julien Cornebis from Google DeepMind. Google DeepMind is the London-based AI research lab for Google, and DeepMind was acquired by Google for $400 million in 2014. So incredible sums of money being invested into this technology. And if you want to understand why Google thought $400 million was worth investing in DeepMind, I suggest you go to Julian's talk. He's got some great videos. It's really exciting stuff. It's at 2 p.m. today. And he's going to tell us what DeepMind is and why the work that they're doing there is so exciting. And you'll get a feel for what those breakthroughs are and what the future holds for us. Okay, so we've got a couple of other short presentations by some colleagues. So Joachim, are you ready for Angry Birds?
It's not my turn yet, is it?
Okay. How about we have the presentation on... Sorry?
Christof is here.
Christof. I beg your pardon. Christof?
Hi, morning.
Do you want to come up and say a little bit about consciousness?
Sure. Thanks, Mike. So consciousness has been one of the oldest philosophical problems in rational thought. And by consciousness here, I simply mean the fact of having experiences, whether you are the feeling that you are you, or the feeling that you are happy, or in pain, or seeing color. Those are all different aspects of consciousness. And the questions, of course, has been forever, can we have an empirical based theory of consciousness that's amenable to test, or is this going to be forever a problem that remains beyond the bound of science? For the last 40 years, there has been major progress in the mind-body, in this particular aspect of the mind-body problem, in the sense that people agree we can all study what's called as the neuronal correlates of consciousness. In other words, we can study in humans or in closely related species, we can study what parts of the brain are specifically involved in having conscious experience, as compared to what part of the brain are involved in generating behavior that may or may not be conscious. And of course, we know since Sigmund Freud that most of our behaviors involve and for most of our behavior, consciousness either comes after the fact or isn't involved at all. So it's a separate research track in the brain sciences and in the clinical sciences, trying to identify in humans and apes and a few other related species what are the specific areas of the brain that are involved in consciousness. Now, even if that program ultimately comes to a successful conclusion, as there's no reason it should, I mean, it's a standard scientific problem trying to identify which parts of the brain are involved in generating conscious perception, that doesn't answer some of the more fundamental problems around consciousness, namely, what is it about any physical system that gives rise to conscious experience? For example, does this thing here, does this iPhone have conscious experience? Does a newborn baby have conscious experience? Does a fetus have conscious experience? Does a patient who's severely disabled have consciousness? Does an animal whose evolutionary and structural similarity with us is quite different, let's say an octopus or a squid, it's very different, it's capable of very complex behavior, does it have consciousness? What about bees? Or what about group minds? Right? There's been forever theories that claim that group mind, for example, the beehive that consists of 10 to 20,000 bees by themselves, has some consciousness. How can we ever how can we understand questions like that? In particular, of course, now with the rise of AI, we're being challenged by systems that behave like if they had consciousness. So certainly, if in a patient, if you talk to a severely impaired, neurologically impaired patient, and the patient could drive a car, or could play chess, or could answer any of a large number of questions, there would be no doubt you would say that the patient is conscious. So how can we deny consciousness to systems, to artificial systems that have those behaviors, but that have, of course, very different, radically different underlying circuit and evolutionary history? So what this calls for is a general theory of consciousness that tells us what are the general conditions formulated in a relevant mathematical language, the language of causality and of information of Bayesian networks? What is the general theory that tells us which system can and cannot have consciousness? And the dominant theory there is a so-called theory of integrated information by Giulio Tononi, an Italian-born American neuroscientist and psychiatrist. And it comes to a number of surprising conclusions. So one of the things that it gives rise to a number of testable predictions as to how you can measure consciousness in people, which is actually not an easy thing, particularly trying to measure consciousness in patients that are severely impaired. So right now we don't have what's called a conscious meter. We don't have a reliable way to measure whether this patient in front of me, who may be paralyzed, who may be severely traumatized because she's been in a car accident, and who may just groan or have some rudimentary behavior. To what extent this patient can be conscious? But the theory now gives rise to tests where you can measure the presence of consciousness in this particular patient. The theory also comes to some surprising conclusion with respect to consciousness. So it avers quite clearly that any consciousness depends on the circuitry of the underlying brain, and if the circuitry is of a particular type, particularly of the type that's present in these deep convolutional networks that we already mentioned, which is sort of the standard tool right now in AI. These are feed-forward networks. They can be very, very deep, up to 20 or 30 layers. That such a system will not have consciousness, which gives rise to the surprising conclusion that the absence or presence of consciousness cannot be detected by a simple Turing test, right? That the Turing test is more a test about social psychology. To what extent can you get people to accept an artificial creature like Ava in Ex Machina, or Samantha in Her? To what extent will people accept that this person is sentient? That doesn't answer the question, is that person actually sentient? So the theory says that you have to look at the circuitry, that certain types of systems that display complex behavior equivalent or possibly even superior to that of a human, may not be consciousness. So in other words, it dissociates consciousness from intelligence. That's really the key message, that those are really two different things. That you can have a system that behaves intelligent in a complex world, including learning, but the system may or may not have any conscious experience. In other words, you could have sort of a complete zombie, or what philosophers refer to as a zombie, a system that acts as intelligent as you and I, but that doesn't have any conscious experience.